Hello guys, welcome to this channel. Today we're going to learn how to simplify expressions involving square roots or expressions involving radicals. All right, so I'm going to go ahead and just show you all the work so that we can begin to think, together, think ahead together to see how we can solve these problems. All right, first of all, I'm going to start from this symbol, okay? Sometimes the square root symbol can be written like this, all right? So, which means that if I wanted to write the square root of 8, I would just write square root of 8 like this. Okay, or I can write it like this, right? There's a little 2 right here. So they mean the same thing. But then note that if I write this way and have 2 here, this is a little different, okay? So the symbol here does not have a hook like the square root has. So you see this is a hook right here. Let me use a red to show that. The difference is this hook here, right? So this one here, the symbol here, is the symbol for long division. Okay, so if you wanted to write 8 divided by 2 in the long division form, you can do this. All right, so I hope you have seen the difference between those. All right, so we're going to get started, and we start with the first problem here. Some of you already know how to find square root of numbers, but I just wanted to say that in order to be able to find square root of numbers, we have to be very good with multiplication. Okay, how to multiply numbers. All right, because square root comes from square, the square of a number. You know that when you multiply a number to itself, you get the square of that number, right? So in order to get square root, you will have to do the opposite of that. So now let's go ahead and look at 9. 9 is 3 times 3, right? So since 9 is 3 times 3, so if you want to find the square root of 9, it means you have to just keep one of these copies. Okay, so a number multiplied to itself gives the square of that, right? So in order to get the square root of that number, you have to go through this process. So the final answer is going to be what? 3. All right, let's go to the next problem here. 25, it's easy. So there are two numbers that I can multiply to get 25. So those only numbers will be 5 times 5. So 5 times 5, I remember that we said that we can use a dot in place of multiplication, right? Okay, so 5 times 5 is 25. So because of this fact, the square root of 25 will be 5. Okay, so let's look at this letter C. Okay, for this problem here, we have the square root of 32. I'm thinking maybe I should try 6 times 6. But then 6 times 6 is 36. And 36 is a little bit more than 32. So we can't do 6 times 6. We can't do that. So we need to think. So the other choices of numbers that we might have would be a number between 5 and 6, right? So it will be a number between 5 and 6, but it's not going to be very easy. It'll be a decimal. You're right. So if it's going to be a decimal, we don't want to do decimals when simplifying radicals. Okay, so you're going to try to avoid decimals. So here we want to see what other routes we can go. All right, so let's look at what options we have. So I know that 32 is 16 times 2, right? So, but I can find the square root of 16. What is the square root of 16? Hmm, think about it. Square root of 16 is 4 because 4 times 4 equals 16. But then, what about the square root of 2? Do we know that? Oh, square root of 2 is irrational. It's irrational, which means if we want to try to find square root of 2, it'll give us decimals. And they're, the decimals, and you don't have recurring decimals for irrational, numbers. So because of that, we'll just move it over, and it will be 4 and square root of 2. So this is how you write the expression, okay? And this is how you read it. You say 4 root 2. 4 root 2. So instead of saying the square root of 2, you can just say root 2. And that's how you read it, okay? Let's go to the next one. So this is 8 here. Again, I know 3 times 3 is 9, which is greater than 8. So I don't want to do 3 times 3 for 8. So I don't want to do 2 times 2 because 2 times 2 is 4. So it's smaller than 8. So what I can do is, okay, just go ahead and just break it to 4 and 2. 4 times 2 is 8. But then I would just go ahead and take the square root of 4, and the square root of 4 is 2. Then go ahead and take the square root of 2. Again, we said the square root of 2 is irrational, so I'm just going to move it over there. So which means we end up with 2 root 2. Great. All right, let's keep going. Next one is going to be square root of 12. I know 12 is 6 times 2. Let me try 6 times 2 and have square root of 6 and square root of 2. Square root of 6, I don't know. It's not 2 times 2 and it's not 3 times 3. So, meaning that this is not going to be helpful when trying to simplify the square root of 12. So, let's go ahead and just take that away quickly and think of something else. So I'm going to think about, I know 12 is 4 times 3, right? Okay, I think this might be a better option. 4.3 means 4 times 3. So go ahead and take the square root of 4 and take the square root of 3. So square root of 4 is 2. But the square root of 3, again, that's going to be behaving like the square root of 2. They're both irrational. So I'm going to have square root of what? 3 like that. Okay, cool. All right, let's go ahead and try f. So for f, we have 9. We have 16, and 9 is the denominator. 16 divided by 9. Okay, so if we divide 16 and 9, we end up with a mixed fraction, or we have a decimal fraction. So we don't want to do that again. So we don't want to use your calculator. So what we can do here is, oh yeah, there's a theorem that we can apply here. So if you have a fraction in the radical sign, you can take the square root of the individual numbers. Okay, so the square root of 16 is 4, and you can divide it by the square root of 9, which is what, 3. Done. That's how you do problems like this one. Okay, because doing it differently might be very complicated. Okay, all right, let's do the G part. I want you to think about how you can do this. This is a product of two radicals, okay? So how do we solve this problem? Oh, again, let me think about something I can do. I know that I cannot simplify the square root of 12. We already found the square root of 12 here. It was 2 square root of 3, right? 2 square root of 3. So which means 12 in itself is going to reduce to 2 square root of 3. And then we're going to multiply this by square root of 3, right? Okay, so what is the square root of 3 times the square root of 3 here? Square root of 3 times square root of 3, there's a theorem that says that we can multiply them together to give square root of 9. 3 times 3 is 9. They both have the radical sign, so it will be 2 square root of 9. 2 square root of 9. But then look, the square root of 9 is 3. That means 2 times 3, which is equal to what? 6. Great. So the final answer is 6. But let me show you something that you can also do. You see 12 times 3? So what is 12 times 3? That's going to be 36. Oh, that means we could have done it like this. That means 12 times 3 is 36. Okay, what is square root of 36? That's going to be what? 6. Oh, this one appears to be easier. So I will do this all day. So I prefer this other method to the first one. All right, let's do the problem H. I want you to pause this video and try it yourself and see if you can do it. All right, so let's do it together now. So what I can do here is I know the square root of 18 might not be very easy to do, but let me see if I can break it down. I know that 18 is 2 times 9, or let me say 9 times 2. All right, so let's do it as 9 times 2. It's easier to have the larger number first. So 9 times 2. I'm just going to go ahead and take the square root of 9 and take the square root of 2. Square root of 9 is 3, but square root of 2 is irrational. I'm just going to bring it down and drop it. And then I have the square root of 2 in the bottom here. So this is division, right? So fraction division. So I can actually just cross the square root of 2 and the square root of 2 out, and that will be 1. That will be 1. So that means I'm left with 3 times 1 divided by 1, which is exactly what? 3. Good. And then remember that you might have another way to do this problems. Okay. Okay. So maybe another way to do this problem will be, think, 18 divided by 2. So meaning that we could actually just combine both of them and divide it one time. So 18 over 2. That means, what is 18 over 2? It's 9. And what is square root of 9? 3. Yay. Good. Means we can do these things differently and we'll still be fine. All right, let's go ahead and do the square root of 8 plus the square root of 18. All right, we can do the square root of 8 because we already figured that out from here. So, all right, so square root of 8 is 2 square root of 2, right? So square root of 8 is 2 square root of 2. We know that. All right, plus, let's go ahead and do the square root of 18. Oh, we just figured out from here, let me show you. From here, that the square root of 18 is 3 square root of 2. So I'm just going to write 3 square root of 2. How I know that is because this 18 is 9 times 2, and 8 is 4 times 2. So what I'm doing here is taking the square root of 4. If I take the square root of 4, that will be 2. And that's how I got this first 2 here. Then I put square root over there. And the square root of 2 remains the same, and because it's irrational. And again, the square root of 9 is 3. Look at the 3 over here. And the square root of 2 remains the same. It doesn't move. All right, good. But then we're here. Doesn't mean that can we just stop here? Maybe there's something we can still do. This two expressions here, this expression here, they're called like radicals. So you can see that they are alike. The square root of 2 appears here, and the square root of 2 also appear. You can see the square root of 2 here and the square root of 2 here. So in this situation, you're just going to keep that square root of 2, but you can combine the whole numbers here. This number is outside the square roots. Okay, so it'll be 2 plus 3, right? 2 plus 3 is going to be what? 5. This is the way you do addition and subtractions of numbers with square roots, just like you would do for when you add fractions and subtract fractions. You want to make sure that they have the same denominators before you can add and subtract. So for radicals, when you're simplifying by adding and subtracting, you want to make sure that they have the same radicals before you can combine them. So that's why we couldn't just combine square root of 8 plus square root of 18 and say 8 plus 18. It is not always true, so you can't do this. But if it were multiplication, we could. If it were division, we could. So we can't do that. So be very careful not to add and subtract directly. So you have to convert, make sure they have the same radicals before you can do that. So for the final, think about this final one here. So what can we really do here to simplify this result? The only challenge we have here is the denominator here. The denominator has a square root on that. And in math generally, and in algebra generally, you're not allowed to leave your expression like that. So what you can do is the process of rationalization. Okay, the denominator is irrational, so you need to make it rational. And that process is very easy. Okay, I'll just show you how I do this. Maybe it would be helpful. So this is square root of 2, right? We really don't need that square root over there. So you would write 2 and make the square root disappear. And now I'm just going to move this 3 over, right? Because I made the square root of 2 disappear and converted that to 2 directly, I will now have to make the square root of 2 appear on the numerator. So this is how you do it. Easy, right? So there's something that I'm not showing you. So let me go ahead and show you over here. So we had 3 over square root of 2, right? So what you would do to rationalize, I was saying rationalize. So something that's irrational, you make it rational somehow in a way, okay? It's not completely, but that's the process. So you would multiply the denominator by itself. That's how you rationalize something. So you would multiply the denominator by square root of 2 and likewise the numerator. So when you do this, it becomes 3 times square root of 2. That's not going to give us square root of 6. Be careful again not to multiply this 3 and 2 to get square root of 6. Don't do that. So it'll be 3 square root of 2, and then you divide it by 2 times 2 is what? Square root of 4. So that will be square root of 4. But then look, it becomes 3 square root of 2 divided by what's square root of 4? Square root of 4 is 2. So this is how you do it. You see, the whole explanation here is exactly what I showed you here. That's the trick. Again, write your 3 and then make the square root disappear from the denominator, and that will be 3 over 2. But then, since you want to rationalize, you want to make sure that this same copy here of square root needs to go over to the denominator as a product, and this will be your final result here. So this is the end of the lesson, and I hope that you've learned something from here, and it will be fun when you start, finding the area of a shape, or finding the perimeter of a shape, or find the distance and the length of a line segment. Thank you. Make sure you subscribe and then come back for more videos.